Hello everyone, here we have a beautiful question of the electric dipole moment and potential due to the electric dipole. So here are 4 point charges given, minus q plus q and then minus 2q and plus 2q. These are point charges which are fixed. Here is the point O and from point O at a distance r there lies the point P. At point P, the electric potential due to this entire charge configuration is this much, minus alpha QL upon R square into 10 to power 9 volt. And we have to figure out the value of this alpha. Got it? First of all, let us go through few fundamental things. If there is a point charge minus Q, there is another point charge plus Q. And let's say they are at a distance 2L apart from each other. Then the electric dipole moment in physics is directed from minus charge to plus charge, which we indicate as P vector. And the magnitude of the P vector is written as the positive charge magnitude, which is Q, and the straight line distance between these 2 point charges, which is 2L in this case. Got it? Now, suppose we make a straight line joining these 2 point charges, and from the center of this straight line, we go at a distance r, and here we wish to figure out the electric potential. So, formula for the electric potential V is Kp cos theta by r square. And here theta is measured like this. This angle is theta. And this is written as small k. Agree? So we'll be utilizing this formula for obtaining the electric potential at this point P. First of all, if we check from here, minus q to plus q, the straight line distance is given to us. This is 2L. So here we can frame an electric dipole moment which we indicate as P vector. Okay, the P vector goes from minus q to plus q, and the magnitude of that P vector will be equal to q into 2L. Take the magnitude of the positive charge multiplied with the straight line distance between them. Now there is another electric dipole visible. Focus on these 2 charges, plus 2q and minus 2q. From minus 2q to plus 2q, there will be another electric dipole moment which will be directed like this here. Okay, and we will figure out its magnitude. We call it, let's say, P dash vector. The P dash vector is directed from minus 2q to plus 2q. Let us write the magnitude of that P dash vector. P dash vector will have the magnitude of the positive charge, which is 2q, into the straight line distance between these 2 point charges, plus 2q and minus 2q. The straight line distance between these 2 point charges is given as 4L. So write here 4L. Agree? This we are writing in turn as 4 I am keeping outside, and then writing it as q into 2L. 4 we have kept outside, then q into 2L. This q into 2L is already something. It is equal to P. So here you will write 4P. So basically we got the magnitude of the second dipole as 4P and directed like this. The first dipole has its electric dipole moment directed like this. Since electric dipole moment is a vector quantity, we can take their resultant. What I mean to say, magnitude here is 4P and magnitude here is only P. 4P in this direction, P in that direction. So we are left with what? We are left with 3P. Simple vector addition, subtraction, whatever you remember. 4P in this direction, P in that direction. So its equivalent diagram is with us. We should show here an electric dipole having the magnitude 3P and direction like this. From this electric dipole center, we go at a distance r apart and we locate the point P at which we have to figure out the electric potential. Now, if we check the angle, so the angle is taken, if you check the sense here, this is the direction of the P vector. From the direction of P vector, you have taken the angle like this. So here is the direction of P vector. And from the direction of the P vector, we always consider the angle. So this should be the angle for our calculation. Here was data given as 60 degree. So we will be using the data as 120 degree for theta. Agree with this? Whatever is the arrow of the P vector, check the head of the P vector. Here was the head. From this head, you consider the angle. Okay, so here was the head. From the head, you consider the angle toward that point P. Done. Now, let us put up the data for the calculation purpose. K is 9 into 10 to power 9. So put up this data, 9 into 10 to power 9. The P here is actually 3P. And the 3P can easily be written 3 into. At the place of P, we will write Q into 12. So this magnitude is basically 6 QL. Agree? So at the place of P, we will put 6QL. Then cos 120 degree. This would be the angle useful for us because P vector's head is in this direction. From the head of that P vector, we consider the angle divided by the distance is R only, so R square. Agree with that? Let us simplify and match it with this given format. We all know that cos 120 degree is how much? Minus 1 by 2. Cos 120 degree is minus 1 by 2. So, putting up the data and simplifying it further here and doing the remaining calculations here. 9 into 10 to power 9 into 6 QL. This cos 120 degree is minus 1 by 2. So putting that 2 here and then we have here R square. Simplifying it further, 2 and 6. Here we can write 3. Now we have to match it with the given format. So I'll segregate QL upon R square. So here is the minus sign. Then we have to segregate that term QL upon R square. We have segregated that term. Minus sign QL upon R square into 10 to power 9. 10 to power 9 is already available. Here is this 10 to power 9. Now what we are left with? We are left with one number 3, another number 9. And 3 into 9 would be 27. So this number we will write as 27. Check it again. 9 into 3 is 27. 10 to power 9 has been taken here. This is QL and there is R square. The question was asking us the value alpha. So the alpha comes out to be 27. That should be our answer. I hope you enjoyed the calculation. If you enjoyed it, please like this video, share it with your friends and kindly subscribe to this channel. Stay awesome. See you again and thank you.